Okay, we're going to do lecture 9, part 1 here. First video here, we're just going to be talking about the definition of a function, what exactly a function is, and then we'll move on to finding the domain of said function. So, first off, with this college algebra course, there are two different ways that you can define a function. You need to pick which way you're going to do. You do not need to know both ways, you just have to know one of them. So the first way to define a function is a correspondence between two sets. Okay, so you can define a function as a correspondence between two sets, or you can define a function as a machine with an input and an output. Okay, honestly, either one of these will work. I have always used the machine definition, but some of you guys, the correspondence definition makes more sense. So you truly get to pick. You do not have to know both of them. So first one, a correspondence as a function. Now, when I tell you guys that you have to define these and you get to pick which way, you have to give a definition in words. You also have to draw a picture. So function as a correspondence. A function is a correspondence from x into y that associates each point in the x set a unique point in the y set. Okay, in simpler terms, you could say that a correspondence is where each x has only one y. Okay, so a correspondence is going to be where each x has only one y. Now, how do I draw the picture for this? Well, the picture that they have you guys draw is two boxes. One of those boxes represents your x set. The other box represents your y set. There are points in your x set, and those points correspond, that's why it's defined as a correspondence, correspond to a point in the y set. Okay, and we would label this as the correspondence. Okay, so that is your definition of a function as a correspondence, and this is the picture. You are required to draw a picture. So this is the picture that you would have to draw if you're going to define a function as a correspondence. Okay, the other way that you can define a function is as a machine. Okay, so defining a function as a machine. A function is a machine that associates with each input element some unique output element. Okay, another way you can say that is that each input, wow, not spelling very well right now. Another way that you can do that is each input has only one output. Okay, each input has only one output. Now, how do I draw the picture? You guys in Algebra 2 may have seen me draw it this way. You're going to draw almost like a Frankenstein head. And this Frankenstein head, that is your machine. Okay, and how does this function work? Well, you're going to have your inputs that enter into your machine, and then your outputs that come out on the other side. Okay, so for your test, guaranteed this is going to be on your test. They're going to ask you to define a function, and they're going to tell you that you have to draw a picture with it. You can either define your function as a machine, or you can define it as a correspondence. So you have to pick one of those two when you guys are defining these. Okay, now, just some other things I want to talk to you guys about with functions. A function or a relation. So a function is going to be when each input has only one output. Emphasis on that only there. So, which of these down here is a function and which of these is a relation? Well, how many outputs does this input x have? It's got one, y sub 1. How many outputs does this x sub 2 have? It's only got one. Okay, yes, they're the same, but it only has one. So this is an example of a function. However, when I look at this x here, this x has an output of y. That same x has an output of y sub 2. So this input here, this input does not have only one output. It has two. So this is an example of a relation. And it's important to be able to look at these mappings, look at tables, and be able to identify which one of these are functions and which one of these are relations. Some other things about a function. A function consists of three parts. It consists of your domain, which another way that you can talk about your domain is your x values or your inputs. Okay, as a correspondence, we talk about x values. As a machine, we talk about inputs. Part two is going to be either the machine or the correspondence, however you're defining it. Correspondence. And then lastly, part three, we have our range. Now, your range is the same thing as your y values or your output, depending on how you talk about your functions. There is a function, or there is a certain notation that you use when dealing with functions. That certain notation is f of x, okay? This is not multiplication. This is not f times x. You guys heard me say it there. It is f of x, okay? Another way that you can call it is f at x. I always think that looks like fat x, and it makes me laugh a little bit. But this is your function notation. We will talk more about that in lecture 9, part 2. And then the last thing that I want to go over with you guys here is just this little notation identifying each of these parts here. Okay, this x, whatever's inside those parentheses, is your domain element. That is going to be your x value, what's in there, okay? Whereas on the right, this big thing is called your range element. And this is how we find our y value, because basically you will input whatever your x value is into each of those x's there, and then you will simplify it to tell you what the y value is. And then this f is the function, okay? This is the name of the function. And that f tells you which function you're looking at. We're looking at the function f. If it's area, it might be a of x, so that's your area function, your volume function, v of x. It just tells you what function you are looking at, okay? Next video, we will look at how do we find the domain of these different types of functions.